This lecture is about the metric system, about standards and prefixes. So sometimes people are a little intimidated by the metric system because they're so familiar with the English system that we use in everyday life. Here's a cartoon kind of playing on that fear, in the multiple meanings of the words feet and meters. But let's get started. So why the metric system? Why do we, not use the English system? Well, it was decided when countries started communicating more and more and had trade routes with each other that it would be very advantageous to use the same system to measure things. So when somebody was trying to sell you, 12 hogsheads worth of goods and you weren't familiar with that, you want to make sure that you're getting your money's worth and whatnot. It's just easier if we're all on the same page communicating with the same thing. The French, the superpower at the time, held a big conference and said, okay, let's come up with a new system to measure things. And that system was the International System, System International, SI, or metric system. We use it in physics, we use it in science. We don't use it in everyday life in America, but we're one of the few countries that doesn't. And, I don't know if we ever will change, but we need to know the metric system. So how it works is if you're looking at a quantity such as length, then the standard unit for length is the meter. In the metric system, you can divide those meters into powers of 10. And then to represent that, we use a prefix that goes in front of the word meter. So if we used the word milli in front of meter, or the prefix milli in front of meter, what we're really talking about is a millimeter. The symbol would be a small m and a small m, and 10 millimeters would equal 1 centimeter, or 1,000 millimeters would equal 1 meter. So it's all powers of 10. The standard for length being the meter. The standard for mass would be the kilogram. Time would be the second, which is the same as we normally use. Temperature, we'll use the Celsius scale, or a lot of times we'll use the Kelvin scale when we need an absolute temperature scale. That would be like for Q equals MC delta T, where we're looking at heat transfer or something like that. But Celsius would be the standard metric or SI unit. Area, square meter is what we're usually going to use in this physics course. If we were taking astrophysics, a lot of times what we're going to use is square centimeters. Astrophysics tends to use a CGS system rather than a kilogram meter second system. Volume would be the liter, and a cubic centimeter is 1/1000th of a liter. So this is also a metric unit given by, if you had a cube and you multiplied one side times the other side times the height, that's where you get the cubed from. But we can also define it by just saying how many liters is it. Cubic meters would be what we'll typically use in this class. Speed and velocity would be meters per second. Density would be kilograms per meters cubed. Force is the newtons. Stress would be pascals or kilopascals. Pascals would be the standard. Kilo means 1,000, so it would be 1,000 pascals. Power, we're going to use watts. Energy, we're going to use joules is our standard. Electric currents would be amps. Here's a list of all the prefixes, but in your textbook on table 1-4, it's a more extensive list of the different prefixes. These would be all the ones that we typically use. If we're using current, it's very common to have pico amps or things like that. If we're using a flash drive, we might have gigabytes of data on that, so that would be the G. Where's the standard? Well, remember 10 to the 0 power is 1. This is where your standard goes right here. So this would be either the word meter or the word liter or whatever it is that we're trying to give powers of 10 of. If we had 1,000 meters, we'd have a kilometer. like this. If we had a million, we would have a megameter. Now notice that we're going to use the same letter more than once. So a capital M, being mega, is going to be different than a lowercase m, meaning milli. This is 1/1000th. This is a million. So it's important to, make sure that your capitalization and your punctuation is correct, or people won't know what you're talking about. When converting within the metric system, it's just simply a matter of moving the decimal point or changing the exponent to indicate that you moved the decimal point. So when we're doing this sort of a thing, we have 1,000 meters, well, that's 1 kilometer. All we have to do is move the decimal over. And if you look at the previous chart, depending on how many places you go from meter to kilo, 1, 2, 3, that's how many places you move the decimal. For you and your purposes in this class, you need to memorize what a milli is, what a killi is, what centi is. Those are going to be really common. Hecto, not so much, but milli, centi, kilo, those are absolutely must memorize those. You're going to use them a lot, and over the time you'll just memorize them because you use them so much. Depending on what type of science you're doing, you might work with pico amounts of material or nano amounts of material, nanotechnology, that sort of thing. You'll get used to using that a lot more. One of the symbols is micro. It's a Greek letter mu. It's kind of like a backwards Y. That's pretty common as well, micro amounts of a certain substance. Okay, so things to remember. The short forms for the metric units are called symbols, not abbreviations. Metric symbols never end with a period unless they're the last word in a sentence. Metric symbols should be preceded by digits, and a space must separate the digits from the symbols. Just some grammar. Symbols are always written in the singular form. Now, that's a really important one because the S also stands for seconds. So if you look at sample number 4 here, and somebody saw this, they might think it was kilogram seconds. Well, that's an actual thing, kilogram seconds. It's a way that we would measure something which would be different from mass. So make sure you don't plural the symbol by putting an S after it. Okay. The compound symbols must be written out with an appropriate mathematical sign included. Okay, so if you have 30 kilometers per hour, or kilometers divided by hours, that's the right way to represent it. You could also say kmh to the -1 would be another way to represent it. Typically, it's not appropriate to do this, although when you see me do story problems, I might do that. Well, forgive me. We're not supposed to do that. So it's okay to write kilometers per hour if you write the whole thing out. I think people would understand what you were talking about if you wrote that. Lastly, the meaning of a metric symbol is different depending on if it's lowercase or capitalized. Like we talked about, mm is millimeters, 1/1000th of a meter, and capital M, little m, is megameters, 1 million meters. So there's a big difference. Capitalization is very important. You need to make sure you have that right. Well, that's it for the metric system, the standards and the prefixes, and you can find this information in your book. I hope to see you in class.